Oh no, coffee is. Cool. Oh, these slides are also in my SlideShare, which I probably should have put on this page. Yeah. So if anyone wants to grab if anyone wants to keep the slides open to refer to when we're doing the exercises, they're on my SlideShare. Okay, 2 more minutes.
There's like 2 seats over here.
I need more coffee. I feel bad drinking all your coffee. It's delicious. Okay, I'll grab some more coffee before we start. Sorry.
White space. I'm glad that you figured it out. I remember I looked at that store
Thank God. Yeah. Oh, should I do the thing with the thing for the thing?
You don't need to do this. You're good.
Cool. So no need to record the slide pandas of pandaness?
No, I want to see what I'm doing over here.
Oh, I saw some slides. Oh, you're doing fancy. Yeah. Just in case. Yeah, no worries, no worries. Super happy fun times. Okay, cool. Yeah, let's go ahead and get started. So this is Introduction to Spark ML. Hopefully that's what you're all here for. If not, I won't be particularly offended if you leave. It's cool. I think it's fun anyways, though, so you should hang out with us. This is the second in a series, and so it's sort of building on top of some things we did earlier. But if you already have sort of a basic understanding of Spark, you should be fine. And if you don't, we'll find out how that goes. If you enjoy this one, we'll take a poll at the end of class as to sort of what the next topic should be. I'm thinking maybe we'll focus some more on Spark SQL for the next one if that's a thing enough people are interested in. So I'm Holden. My preferred pronouns are she or her. I'm a co-author of the Learning Spark book, which hopefully some of you have bought, because I like selling books. I'm a software engineer at IBM Spark Technology Center. I think it's a really awesome place. We're hiring, of course, Spark developers, as is Alpine. Alpine is also hiring, and they're very generously having me talk here, even though I have moved on to IBM.
Come back anytime.
You have wonderful iced coffee, so I promise I will be coming back sometimes. If you want to follow me on Twitter, I complain a lot about American healthcare, talk about my scooter, and occasionally talk about Spark. So you can find me on Twitter. The slides for today's talk are on my SlideShare, and it might be useful to sort of just bring that up in a page and keep that so you can refer to it later on. If you want to connect with me for like business or something, whatever that is, you can find me on LinkedIn, just like everyone else. Tell me that you were in the workshop so I actually remember who you are, because I'm not great with faces and there's a lot of people today. So just let me know where I met you so I can actually add you back. So we have a bunch of really nice people who have agreed to be TAs for today. And would the TAs like to stand up so people can see who they are?
We're all in one spot.
Okay, cool. So they'll spend... I'm sure some of them will move around when we're doing the exercises and not just stay over here. Did you want to maybe say your name?
I'm Anya.
And stuff?
I work at Alpine. If you have questions about Alpine, come find me.
I'm Anand. I work at Glassdoor. So.
Hey, hi, I'm Pranav. I will be working with KPI Partners, and before that I was working with TNP as a big data platform engineer.
I'm Rachel. I work with Alpine as well.
Yeah, I'm also at Alpine. I write some stuff in Spark.
Cool. So during the exercises, if you get stuck, you don't have to wait on me. There's lots of wonderful TAs. And they even found a bunch of mistakes in the slides that I fixed, hopefully. So they're really awesome people. If we wanted to clap for the TAs, that would be cool. But if not, I'll just do that awkwardly myself. Okay, cool. That was the thing. So what are we going to explore together? I'm going to sort of talk a bit more about my assumptions about who you all are. If they're wrong, it's okay. You can ask questions while I'm going. That's totally okay, and we'll just modify it as we go. We'll talk a little bit about the two different ML APIs in Spark. We're going to focus on just using the Pipelines API today for actually doing our exercises, because I love the Pipelines API, and it's the new fancy thing, and we all want to do the new fancy thing, right? So we'll run through a really simple example. I'm probably actually going to skip this CodeGen Fun Times thing because it's exciting, but I haven't been able to trick people into merging it yet, and my plans to actually get it merged are on hold. Then we'll have some fun exercises, and then we'll talk a little bit about how model saving and loading works as well. It's kind of one of the less well-developed areas in sort of Spark's machine learning stuff, so it's going to be kind of a little hacky. The same thing with sort of serving options. So once we've made a machine learning model, sort of a lot of us want to use it in a real-time type platform to make recommendations, and we'll talk about some of your options there. Just so I can get a feel for like sort of people's backgrounds, how many people are like actively doing sort of machine learning work either in their job or school or whatever? Cool. And are the rest of the people interested in doing machine learning work or just interested in learning more about Spark in general? Both. Okay, cool. Awesome. That's great. Thanks. So Spark has a lot of different pieces. Today we're going to be focused on Spark ML, and we're also going to take a little detour into Spark SQL and data frames because the pipeline API is built on top of that. But we're not going to really cover streaming or any of the like graph stuff or the community packages all that much today, although we will use a community package to load our data. So I'm hoping you're all really nice people. If you're not, don't want to know. Pretend to be nice. I'm hoping you have some knowledge of Apache Spark. If you don't, it's okay, we'll work with it. If you have some knowledge of SQL, you'll probably find this goes really well. And there are probably some things that I'm repeating that you already know. But for people who don't, it's okay. I'm hoping you're all interested in the topic for today and you didn't just come for pizza. And I'm hoping that you're familiar-ish with Scala or Java or Python. How many people are planning on using Python today? Yes! Okay. Scala? Okay, the remainder. Was there anyone who had their heart set on Java? Okay. Not that there's anything wrong with Java, it's just for the work we're doing today, we want to do a lot of it in sort of a shell environment, and the shell environment is really quite powerful in Python and Scala. And trying to do the sort of Java stuff would maybe slow us down a bit. So that's great. So we're going to skip sort of the generic intro to what RDDs are and what data frames are. But, if you have questions about those things during the exercises, feel free to ask the TAs or myself. And we're going to skip setup time. But if you have an old version of Spark, you probably want to upgrade. To do all of today's exercises, you'll need Spark 1.6. Spark 1.5 will work up until a point, and we can work around it if we have to. So if you have Spark 1.5, don't freak out. But if you've got the time, installing Spark 1.6 would be really useful. Oh, and it's very important that you build with Hive support if you're working from source, but probably most of you are downloading the precompiled ones. I'd encourage you to do that because building Spark takes a long time. So there's a bunch of pages to keep open. Depending on sort of what you're working in, you probably should either choose the Scala docs or the Python docs. There's my GitHub, which has this ML pipeline workshop. So there's an IPython notebook in there that we're going to do some of the work in. But you can do it yourself in the Python shell if you'd prefer. My slide share, and then there's the census data that we're going to use to actually train our model today. So for getting the data to work with, you can just get it from the census people. We're going to need to add a header to it, and that's just the census data is a CSV format, but they didn't put a header on it, and we want to use names rather than like column number 6. So I've got a little header here, and if you just go to pastebin.ca/3318687, you should be able to get the header and just add that at the top of your CSV file, and that'll be good. Everyone got that link? pastebin.ca/3318687. Cool. So that's sort of like our setup stuff. What are the two APIs? So Spark has these two machine learning APIs. There's this sort of traditional machine learning API, as well as this pipeline API. And so the traditional API works on RDDs, but it also has like this very compartmentalized view of machine learning. So sort of all of the work that we do to get our data clean or ready for the machine learning stuff, we're doing outside of its like domain. We're doing it with just standard Spark transformations, and it doesn't really have any idea of what we've done to sort of get our data ready. That's okay, right? Like that's probably how a lot of machine learning things are built. The pipeline API more closely remembers like the scikit-learn model, if people are familiar with that, and we can build these pipelines which will have different steps beyond training a model. So we'll do things like word to vec, or we'll maybe use a string indexer to turn a bunch of strings into some numeric values that we can use in our model. And the pipeline API works on data frames, and data frames are essentially, if you're not super familiar with them, you can think of them as just Spark SQL's version of RDDs, or you can think of them as sort of maybe table-like structures. That's not really the best description, but it's good enough to get you through the class for today. And the pipeline API makes it really easy to use all these components together, right? So we can do feature selection combined with other things and sort of make it all very intelligent. There's even some stuff, and I'll talk briefly about it, to do automatic parameter selection in the pipeline API, which is pretty cool. Yeah. So data frames have restricted data types, so we can't just put anything we want in there, but since we're training machine learning models anyways, they have to be data types that our machine learning models can understand, so this really isn't all that much of an issue for today. If you were to try and do some transformations by hand on data frames, like sort of outside of the pipeline API, you'd probably notice that the API is pretty different from RDDs. Instead of being able to do sort of functional transformations, they're more relational transformations. And instead of taking sort of arbitrary Scala lambdas, they take these Spark SQL expressions, and these Spark SQL expressions allow the SQL optimizer to sort of figure out what's going on. So, if we do a group by and then we do some type of reduction afterwards, it's actually able to be intelligent about the group by. And if we just did a group by in Spark, there was like regular Spark with RDDs, there's a good chance it would fall over because the optimizer isn't able to like sort of introspect our code and know it's doing a certain type of reduction. So there's a bunch of different components in the ML API. There's transformers, estimators, and then pipelines to sort of bring these things together. And so transformers just transform a data frame into another data frame. Estimators are something that we train on a data frame that gives us back a transformer. So we can think of an estimator as a model, like linear regression would be a really good example of an estimator, but so would a string indexer, right? Because the string indexer is going to have to look at our data to figure out what the indexes are going to be for the strings beforehand. So there are many things that are estimators beyond just models.
So just a question, like if
Cool.
it is a second, the produces a transformer, again, is that a model or is it a data frame?
Oh, so the
Produces the transformer?
So the estimator, we would give the estimator a data frame, and we would train it on the data frame, and it would give us back a transformer, and then the transformer would work on another data frame to actually predict the values, right, or index the values for us. And pipelines are just a way to glue these things together into sort of a logical flow of things. I think they're pretty cool. So.
Are they all based on top of MLlib? So
Right, that's a really good question. So the question is, are they all based on top of MLlib? And certainly a lot of the early estimators are pretty much wrappers around the MLlib code. But actually as time is going on, we're seeing the MLlib code is being moved into the pipeline code, and new things are being made in the pipeline way, and MLlib is actually becoming a wrapper around the ML stuff. And eventually, we would like to see the pipeline API be perfect and no need for the legacy API anymore, but that'll take some time, right?
yeah, because I found like some transformers are different in the MLlib versus Spark ML. So anyways.
Yeah, certainly some of the transformers are different. In the past, the more featureful one has been in MLlib, but going forward, the more featureful ones will be in ML, just from where we're focusing development.
So all these features will be implemented in both like a data frame ML as well as the traditional ML, or is it there is a
Right. There's no guarantee that the same transformations are available in both MLlib and ML. Certainly that's true for a lot of them because the amount of work to wrap one in the other isn't all that much, so it's generally something that people do. But you can't assume that all models are available in both.
okay.
Certainly some models are only available in each one.
So what about things pre-modeling? So
Right, pre-model.
I understand this is all part of the modeling pipeline. Right?
Yeah.
But like correlations, distributions, all of statistics, they're all part of MLlib.
Right.
Not Spark ML. So just trying to.
Sure. So the statistics stuff
Yeah.
is actually in a number of places. There's a bunch of statistic functionality in core, and there's also a lot of statistics functionality in Spark SQL itself as well. And so probably what we'll see is a lot of the ML pipeline stuff using the SQL statistics stuff, but there, where these things eventually end up living is a little hard to say because my crystal ball is currently broken. But the statistics code is actually duplicated in many cases, which is a bit unfortunate. Cool. So the first thing that we're going to do to just sort of get started is we're going to want to go ahead and load some data with our cat loader. So we've all downloaded some CSV data, right? And the first thing that we're going to need to do is load this into a data frame so that we can start getting ready to train a model on it. Now, Spark doesn't have built-in support for CSV data, but thankfully, there's a Spark packages package available with CSV support. And so this is very convenient. When we want to use a Spark package and we're launching the Spark shell or a notebook type thing, we can just add -- packages and sort of this information about the package we want to include with our Spark job, and it'll do all of the work of including that and making sure it's available on the workers and the drivers and all of that good stuff. And when we want to use it in like a traditional sort of build, we can include it with just its Maven coordinates. But so for today, we're going to have to make sure that when we launch our shell, we launch it with this packages parameter here. And actually, you used it with 160, right?
160.
Yeah, so instead of 130, you can use 160. There's a new version if you're so inclined. But I used 130 and it worked fine. So either way, it's all good. So reading data in with Spark SQL is a little bit different than reading data in with regular RDDs. We use the SQL context rather than the Spark context. And there's actually this read function which gives us back this sort of data frame reader object on which we can specify all of the information that we need to load our data. So we specify like properties about the data, for example, if it has a header, we specify the formats, and then eventually we specify the path by calling load. This isn't really intended to be an introduction to Spark SQL, so I'm just going to go ahead and there's a slide with all of the stuff that you need to do to load your data, adult.data. So you can just use this code. It's in the slides. But if you want to understand it, that's sort of what's going on. And the two options that we specify are that there's a header, because we want to head it in out of that header, and infer schema, and that just asks the package to figure out what the different types are based on the data. We could have also specified a schema or just used a default schema of strings for everything. But since we want to work with sort of numeric types, we want it to be able to automatically infer that for us. And I don't want to go too much into schemas today. So we sort of covered very, very quickly data loading. And we're going to move on to data prep and training. And so I'm going to go through this with one model, and then you all are going to extend it a little bit more. So for those of you working currently in machine learning, how many of would you say you spend more time on data prep and cleaning? Raise your hand. Okay. And for those of you currently working in ML, who of you spend more time on machine learning? Congratulations. You must have a very good intern or just a very, very great data set. Anyways, so as you can see, like this data prep and cleaning thing is actually the majority of the work that we frequently need to end up doing. The actual machine learning part, a lot of us have like the background in statistics, and it's not all that hard. It's like actually getting our data to the point where we can use the tools that we know how to use with it. So this is just a bunch of imports. But I think one thing which is sort of interesting to think about is looking at the packages that we're importing them from. So we can see here we're importing decision tree from the classification stuff. So there's other things that are available in classification. There's also other types of models available. So there's a regression package as well. These parameter things are just so that we can set values. They're not super important, but it's, yeah, probably actually we don't need this import now that I think about it, but it's already on the slide, so you might as well copy paste it. And then for the feature, and these are the things we're going to be using to sort of clean our data, even though it's already pretty clean for us, we're going to use the vector assembler and the string indexer, and you might want to use the bucketizer later at some point, just as a hint for one of the exercises coming up. But there's a lot of other tools that are available in ml.feature. So if you're looking to do some data cleaning, that's a really good place to sort of poke around. And then we're going to import, obviously, our pipeline so that we can put everything together. All right, so the vector assembler is because when we're going to train, we need to train on a vector. And so the vector assembler is going to let us put together a vector of our data that we can train on. So let's sort of look at what that looks like. So our vector assembler is really simple. I'm just saying these are the two columns that I care about. And I went ahead and I just picked the two things that were already doubles that I could just use as features because I'm really lazy. And for you all, you're going to have to do more than that, but I got to do just the easy one. So that's great. So what I'm saying is this vector assembler is going to create a vector called features of the age and education number value. Then I've also got this string indexer, and this is because I want to predict the category, but the category is a string, and the decision tree requires like a numeric for the prediction. So I'm turning my category into a category index, and that's just taking a scan of the category column, and it'll assign each unique value it finds in the category column a unique number, and keep track of that assignment that it's made for us. So this is just a transformer, right? And this is actually something that we have to fit to our data. And so we take our pipeline and we make it this assembler and the indexer. If we were using one of the values from a string indexer in our assembler, we'd need to reverse the order here, but this is pretty okay. Yeah? Awesome. So, right, as I said, they have fit and transform. Fit on our vector assembler is actually, so vector assembler does have fit, and it'll verify the types when fit is called, I believe, but it won't actually do any particular work, and a transform stage. So one cool thing about making a pipeline this way is that once we've made this pipeline, we can easily reuse it on additional data that's going to come in, right? So if you're working in sort of maybe like something with customer data, right, you don't have all of your customer data today. You probably want to predict things about new customers who are going to show up tomorrow. And so by making this pipeline, it makes it really easy to be like, this is my pipeline that I use to clean all my data for when there's new customers coming in, and you can keep using that. And so now we're just going to take this pipeline and we're going to fit it, and it gives us back a model. Now this isn't like a model in really necessarily the machine learning sense, right? Like it doesn't have like any regression thing inside of it, but we fit something to the data, even if it wasn't very smart, and we can go ahead and actually just transform our data. So we can take a model and we can just apply it to the same data that we had and make sure that everything works. This is somewhat more important than you might expect because sometimes things explode. And this gives us back our prepared data. Now we could either like go ahead and then go and like train an actual machine learning model on our prepared data, but we can also like shove it into our pipeline. And so we'll talk a bit more about that. But yeah, this is our pipeline. And as I pointed out, the string indexer is the thing which it needs to be fit, and the assembler doesn't really have any particular thing. Cool. So we can go ahead and we can just, sort of not very intelligently train, or sorry, not very, we can go ahead and manually sort of train a decision tree on this data that we prepared. So for the decision tree classifier, we need to tell it what it's going to be, its label column, and so we're going to use the category index. And our features column is this vector that we made called features. And then we just call fit, it gives us a model, and that's awesome. And we can use this to predict things in the future. Or, we could just take our pipeline and we could put the decision tree classifier at the end of our pipeline, and then we can just call pipeline model.fit, and this will give us something which will take data, clean it, and then call our predictor on it. So it's pretty cool because it's nicely integrated. And we can also individually access the stages. So there's the assembler, indexer, and the decision tree, and these are doing unique things. And sometimes we might wonder what the labels were the indexer was assigning to things, so we can go and access the individual pipeline stages.
So you're defining the stages there.
Yeah, so when we call set stages on a pipeline, we pass in the list of stages, right? And these aren't like pre-fit, right? This is just, we've told it what columns it's going to be working on, and when we call fit, it does the fit for all of the stages. And then when we call transformer, it'll do the transform for all of the stages in the pipeline.
So where is the actual model? Is it in pipeline model?
Yeah, so the actual decision tree model, yeah. So this pipeline model and DT model both have the decision tree. DT model is just the decision tree model. If that was like the only thing we wanted out of it, we could do it this way. But this pipeline model has all of the parts in it, and the very last part is our decision tree model. So we could go and extract the decision tree model out of it if we just cared about the decision tree. But we can also like use it as a complete pipeline for future data that comes in.
And is the model a Scala object?
Yeah, so this is an interesting question. How the model is represented actually changes a lot between, well, so if you're in Python,
Yeah.
the model may be a Scala object wrapped in some Python code, but it may also actually be a Python object. If you're in Scala, it's going to be a Scala object. And same thing if you're in Java. But if you're in Python, sometimes the implementation was such that it was easier to just wrap the existing Scala model and provide the API in Python, because there's this bridge between the two. And in other cases, it was felt that it wasn't worth the work to do that, and like this regression thing is really simple, like I can just store these variables in Python. Why not, right? Except it turns out the why not is that it's kind of expensive to compute stuff in Python compared to Scala, but yeah. So essentially, sometimes it'll be a Python object and sometimes it'll be a Scala object wrapped in a Python object. And if you're interested in figuring it out, you can go and look in like the feature.py file, and if it's extending a Java model, it'll have like in brackets Java model, and then you know it's extending a Java model.
So it depends on the model.
Yeah, it depends on the model.
Oh, I see.
Yeah, each model is implemented differently. Yeah.
So just a question, like, is it all the implementation is done only in the Scala and Spark? The Python is just a wrapper around all that?
A lot of times the Python stuff is just a wrapper around the Scala code, but not always. Especially the earlier MLlib stuff rather than the ML stuff. A lot of the earlier MLlib algorithms in Python were implemented again in Python. But for a lot of the pipeline stuff, it's wrapping the Java objects.
Okay, so
You mean the Scala object?
Sorry, yeah, I use Scala and Java more interchangeably than I
then
should.
To that one, so if we launch it in the cluster, how does it? Because we need to have the Python to be. If we run the like pipeline in the cluster mode.
Yeah.
So how does it behave like, because the resource allocation and everything?
Yeah.
Is it the same way as a Scala?
It's the same as with normal PySpark. So you have all of the wonders of having the second process, which doesn't share the same memory allocation, and all of the fun that entails, which is not a lot. But most of the pipeline models are wrappers around Java models. But if you're using the earlier MLlib API, yeah, you have all of the concerns that you have with normal PySpark code.
Because if you take the yarn cluster or a yarn cluster, because it supports mostly on the Java JVM,
Yeah.
it runs mostly it's running on the JVM.
You can definitely run PySpark on Yarn.
Okay.
There are some restrictions,
Okay.
especially with the shell and earlier versions. So it depends which version of Spark you're using.
Okay.
But you can run PySpark. You just need to have Python on your cluster. And there's actually, if you are big Python users, there is a debate right now as to whether or not to drop Python 2.6 support. Is anyone really tied to Python 2.6?
2.7.
Awesome, great. So you'll all be happy because
2.6.
keeping Python 2.7 is, yeah, cool, yeah. That seems to be the consensus, but I figured I'd try and ask some people who are maybe not on the mailing list. Because the mailing list is pretty biased. Ooh, that was recorded.
So just to recap what you said, the Spark ML models are still, the model is still a Scala object.
Yeah, it's still a Scala/Java object, and it's wrapped in
Python.
in Python.
Okay.
Yeah, but the MLlib ones, it's like sort of a mix.
Okay.
Cool. So we've trained a model. Now we should actually like predict something with it. I'm going to be really lazy, and I'm going to actually predict on the same data that I trained with, which is not the worst thing in the world, but we could really easily overfit. But so we've got our pipeline and model, and we just call transform, and this does all of the steps. It's starting from scratch on the same data frame, so it's going to do the string indexing, do the vector assembly, and then do the eventual decision tree prediction, and it's going to output it as prediction. And then I'm selecting, these are just the two columns that I'm interested in looking at. If we left out select, we would see all of the data, but I'll look at what my prediction was versus what the actual data was. And I'm just going to grab 20 of them to look at in my console. Yeah, cool. So the first exercise is to take sort of this prediction that we get, and we're getting back numeric values, right? Because this category index turned like the individual's Boolean as to whether or not they made more than $50,000 into an index of 0 or 1. But we probably don't know which one was 0 and which one was 1. So we want to turn these back into the actual, human readable values. So the first exercise is to go from this index to something useful. So there is the IPython notebook, and you can use this and sort of like figure it out. Don't look at the answer that's also in there at the same time. I mean, you can, because I didn't think ahead and make a separate solutions notebook. But I'd appreciate it if you don't look at the solution until you get completely stuck. So there's two things we could do. If you're really familiar with Spark SQL, is anyone really familiar with Spark SQL? Cool. So for you two, if you wanted to, you could write select and some if-else statements by hand if you were just really excited about writing Spark SQL. Or there's an inverse in Spark 1.6 for the string indexer model that we used called index to string. So this is a little bit different than I normally do, but I want you to go and look up the documentation for index to string and figure out how to use it. And if you get stuck, there's TAs here and we can help you out. And yeah, this is our first exercise. Let's go have fun. Are there more questions before we go into super happy fun exercise mode?
The index to string, is that in 1.6 specifically?
Yeah, the index to string is 1.6. If you're 1.5, you could learn Spark SQL or upgrade to 1.6. Either way is fine with me. Cool. I'm gonna turn off the microphone. Do, do, do.
Edit it out. It's fine. Don't worry. We're good.
Yeah. Okay, awesome. So I don't actually have the solution in the slides because it's in the notebook, so you should just scroll down in your notebook. And if you don't have a notebook environment on GitHub, you can also just view the notebook and its solution there. And you can just scroll down and see the solution. So, oh wait, I do actually have the solution. I lied to you all. So here's a solution. Is this a solution? Oh yeah, it is. Okay, cool. So the first step is importing the index to string transformer. And then we go ahead and we go to our pipeline model, which I told you was made up of different stages. And since they're in order, we're going to access stage number 1, which is actually our second stage, because 0 indexing. And then we're going to go ahead and we're going to get the labels out of it. So we're going to figure out like what the different strings were that it had used to assign labels. In theory, as one person noticed, there is actually in the documentation, it says if we don't specify the labels, it'll figure it out from the metadata. But unfortunately, the string indexer doesn't set the metadata, so we have to do this work to get the labels ourselves and provide it. But at some point in the very wonderful future, when I have free time and remember to fix that, the string indexer will actually set the metadata value, as will other things. But so for today, we take our index to string, and we say that our input is going to be our prediction, because we want to turn our prediction back into a human readable string. And we're going to turn it into this prediction label. And these were the labels that were used in the string indexer. And it's since they're in order, as a list, it's just able to go in order. And when it gets the number, it goes and looks it up in the array. And we'll turn this back into a human readable value for us. And here I did my inverter and I applied it to the pipeline model, which did the transformation, and I grabbed the top 20. Did anyone do the if-else solution? Did anyone? No. Okay, good call. Upgrading to Spark 1.6 is less work than doing the other one and will probably benefit you more. But I think it's kind of interesting to note that Spark SQL actually has an if-else construct, because that's maybe not part of what you'd think of as part of a traditional SQL engine. So what could we do if we wanted to add other types of data, right? Like we've looked at a string, but it only really had 2 values. It was actually really a Boolean flag, which was encoded as a string. And we've looked at using sort of numeric values, right? So we trained on whatever those 2 things were we trained on. We're going to jump back here. Yeah. So we trained on the age and the education number, which is somehow they assign numbers to various educational values, presumably in some sorted order. But how many of you have to work with data that isn't just doubles? Very few of you. The rest of you are very lucky or have very, very little data, or have already zoned out. Either way, it's cool. Don't worry. So we can actually do a lot of other things to get our data into a format that we can use, and it's not just about getting it into doubles, right? But like we could start with like if we had some free-form English text with tokenizing it, and then we could do word to vec. We could do like hashing term frequency. We can do all sorts of different transformations, and so if you have the time, and I hope you all do, since you're here, you should maybe drink a cup of coffee if you're feeling a little sleepy, because the documentation is maybe not the most exciting read in the world. But I want you to go into org Apache Spark ML feature and find one of those feature transformers, and we're going to go ahead and use one of those transformers on one of the columns that we didn't use in our original decision tree model. And we'll try and train our decision tree with that feature transformed in it. If you didn't get your decision tree trained, that's okay. We could also just like do a feature transformation without having it be part of a decision tree training pipeline. We could just like try and apply one of these feature transformers to one of the columns and just get an idea of how it works. So if you're going to train it and you're like actually going super quickly, either because you're cheating or you've seen this before, I want you to, after you've added a feature to your model, tell me if this actually made your model better or not, right? There's some test data, and you can go and get the test data, and you can tell me if adding this feature helped or not, and you can tell me what feature it was. So exercise 2, super happy fun times, and I'm gonna jump back here so you remember where to go find the different feature transformers we've got in Spark. Cool. Yay! I feel like I'm the only one who's drinking coffee constantly. The level of excitement is just not on par with what I would expect for a place with on-tap cold brew coffee.
We're gonna keep that moving.
I certainly hope so.